Okay, forget about alien invasions or giant meteors rushing toward Earth. There's something much more dangerous lurking in space, and it's called strange matter. While people don't know much about it, experts are sure that under particular conditions, this stuff would be able to eat our planet alive. But to grasp the concept of strange matter better, we first need to understand protons, neutrons, and neutron stars. So, look at your hand. It's made up of tiny cells. If you start to zoom in on these cells, you'll see a bunch of molecules. Keep going, and you'll notice that molecules consist of atoms, which have protons and neutrons in their nucleus. Outside of all that, you have electrons flying around in small clouds. If you could see all this up close, you'd find that these particles aren't crammed together in a tiny space. In fact, there's enough room between them to make you wonder why your hand feels solid at all. But when you touch or press your hand, all those atoms resist the force. And the harder you press, the more atoms stop you. But what if you push really, really hard? Oh, then you'll eventually force the nuclei together and fuse some new elements. Not that this is possible if it's your hand you squeeze really hard, but it can happen with a neutron star. Imagine this. A super powerful and massive star is reaching the end of its life. One of the potential scenarios is that it runs out of its nuclear fuel and, in a blinding burst, collapses under its own gravity. If the star had been massive enough, it'll produce a black hole. But if it wasn't that big, a neutron star will appear in its place. At about 10 miles across, a neutron star is itsy-bitsy when we're talking about stars in general. But at the same time, this small space is unbelievably dense, about 1.4 times the mass of the Sun. It means that just 1 teaspoon of neutron star would weigh a staggering 10 million tons. Scientists say that one day these neutrons can get tired of holding all that weight, and the structure keeping the entire thing together will collapse. This in turn leads to the appearance of a quark star, which is even smaller and denser than a neutron star. Now, let's say the pressure inside a quark star is getting stronger. As a result, things called strange quarks can appear in its core. They've been dubbed strange because, well, they don't behave like normal quarks. I would have gone with quirky quarks, but that's just me. Really simply put, if these strange quarks are numerous enough, they create strange matter, which is unique and unlike any matter you find on Earth. Oh yeah, and it could be the most dangerous thing in our universe. Hang on, I'm getting there. But first, let's conduct a virtual experiment with something more familiar than a neutron star. We'll take an iron atom and start to squeeze it with tremendous force. Sooner or later, the atom's neutrons and protons will blow apart into those quark things. Add some more pressure, and some of these quarks will change, become heavier, and turn into strange quarks. What we have on our hands now isn't an iron atom, but something called a strangelet. That's a tiny piece of strange matter. Oh, don't you just love science? Strange matter is much heavier than our matter. Besides, our dear matter is organized and predictable. It consists of atoms that are, in turn, made up of nuclei and electrons. And our quarks are neatly squeezed into neutrons and protons where they should be. But strange matter, oh, that's a bundle of chaos. Here's where the strange part comes in. Its quarks have no boundaries. They just totally run amok wherever and however they want. Yet, surprisingly among all this particle chaos, strange matter remains stable, very dense, and impossible to destruct. But that's where it gets a bit disconcerting. Strange matter is so stable that it can exist anywhere in the universe, even outside a neutron star. But the worst thing is that strange matter may be contagious. Imagine an innocent jar of honey that suddenly goes nuts and decides to consume everything around – the table, plates, your kitchen, you, the whole galaxy. What a sticky mess. But that's exactly what may happen if strange matter was left to roam on its own. It's like the vampire of particle physics. Anything it touches can be transformed into strange matter itself. Oh yeah, but this stuff is happening way out in space in neutron stars that are thousands of light years away. Well, the thing is, when two neutron stars collide, or when a neutron star crashes into a black hole, these strangelets break free. And at millions of miles per hour, these tiny, or not-so-tiny guys race through space. They can keep going for billions of years, until they come across something they can consume. Sadly, a strangelet won't care whether the object it's encountered is a star or a planet full of life. This space invader would get down to work right away, and it would soon convert Earth and everything on it into more strange matter. So, would there be a way to stop all this from happening? There is one solution, but it seems kind of impossible at the moment. You see, to get rid of strange matter, the only thing we could do is toss it into a black hole. But this escape plan raises all kinds of questions itself. I mean, let's even say that we're at a point where humankind can travel through space, Star Wars style. Okay, but still, in order to deposit the dangerous stuff, you need to get really close to the black hole. Let's picture what would happen as you approach it. First, you'll notice some blackness blotting out the light from surrounding stars. That's just how strong the gravity of a black hole is. Not even light can pass through it, hence the name. As soon as you get to the black hole's edge, aka the event horizon, you won't be able to turn back because it's the point of no return. Even if you were super strong or were traveling at the speed of light, you still wouldn't be able to escape the immense gravitational pull. Plus, you wouldn't even be able to reach the event horizon in the first place. You'd be spaghetti by then. No, for real, it's actually called spaghettification, and it happens when something is stretched paper thin by a black hole's gravitational field. Everything that approaches a black hole gets broken down into individual atoms, and we become long, thin pasta. Not the best way to go, I'm afraid. Yeah, it'd be a tough and dangerous feat to transport and throw this strange matter into a black hole. By the way, how would you transport it there anyway? You could probably use some kind of catapult, but that raises another question. How are you going to prevent the strange matter from consuming this catapult, your spacecraft, or you? Even in this hypothetical sci-fi space travel scenario, it still seems impossible. In any case, at this point, strange matter is just a theory that hasn't been confirmed yet. Interestingly enough, physicists have considered creating strange matter in a particle accelerator, not unlike the Large Hadron Collider. Luckily, they later came to the conclusion that it's impossible to do, since particle accelerators get so hot that they would immediately melt any appearing strangelets. Whew, what a relief! But I'd still like to politely ask them not to try it. Please? Well, it might be comforting to know that even if scientists managed to create some strange matter, it'd be too unstable to live long enough to consume nearby atoms. Plus, the strange matter that would appear as a result of the experiment would most likely be positively charged. Such strangelets aren't too dangerous for our world. Sure, they'd be happy to snack on nearby electrons, but they probably wouldn't provoke that terrible chain reaction I just told you about. Probably. In any case, no strangelets have ever invaded Earth in all the billions of years of its existence, which means that this strange invasion is highly unlikely to happen, at least not anytime soon. So, don't sweat it, and don't worry about that jar of honey sitting on the kitchen counter. Do you think it's possible for a stray space strangelet to infect our planet? Can you say stray space strangelet 5 times real fast? Let me know if you can, and what else you're thinking about down in the comments. And if you love all things space-related, then give this video a like, share it with a friend, and head over to the bright side for more videos to satisfy all your cosmic needs.